Hello everyone. This video, I'm going to show you a kind of interesting question in chapter 3. Just share with you everybody. Okay, this is from end chapter problem on chapter 3. It's 67. And yes, this is a very interesting question. Okay. And the question is, suppose you want to throw an object. Okay, you are A. Okay, you throw an object. Okay, you throw an object, and at the same time, when you throw an object, you have your friend at the B position, and B is h meter above from horizontal. Okay, above from ground. Okay, B is here, and you throw the ball and the 45 degree with respect to the horizontal direction with V now. And when you throw the ball at that moment, your friend B, okay, also not throw the ball. He throw another object, but it's free falling. Okay, your friend B, he make an object free falling, and you want to make your object collide with the object thrown from B here. Okay, and the question ask, okay, the problem is, what's the meaning for speed? Okay, what is the minimum speed, minimum velocity? Okay, what's the minimum velocity of A for the collision happen? For the collision. Okay, so you throw a ball from A, and at the same time your friend throw a ball but free falling from B. Okay, free falling from here. Okay, and you need the minimum speed v naught or v0 to make the collision happen. Okay. Yeah, because if your v naught is not high enough, you will become like this. Okay, if your v naught is so small, it will become like this. Okay, and you cannot make a collision or contact with the object from B. Okay, so you need to have the minimum v naught to make this happens. Okay, that's why the problem want to ask, what's the minimum velocity of A for the collision? Okay, they want a collision here. Okay. Oh, okay. So for this problem, you have two kinds of motion. Okay, from A, it's a projectile motion, and from B, it's a free falling motion. Yeah, it's kind of so. That's why I think this problem is interesting. So yeah, you have two kinds of motion together. Okay, so let's see. Let's say, okay, let's start from here. If the collision happens, the collision happen, if the collision happen, if the collision happens, and the position, the coordinate of A and B, the coordinates of A and B are the same at the collision point. At the collision point. Yeah, okay, this means what I want trying to say is, if A and B, if these two objects collide here, make a collision here, so at this point, at this green point, at this point, these two objects has the same coordinate. Okay, A and B have the same coordinate, or I should say not say coordinate. Sorry, not coordinate. I should say position. The position. Yeah, that's better. Yeah, if A and B collide at this green point, the position of A and B are the same at this collision point. Yeah, that's why the collision happened, right? Okay, that's okay. I hope you understand this point. Okay, and so okay, so from this we let's say okay, let's see. Oh, sorry. So how to solve this problem? First of all, we write down the equation of motion from these two object. And I believe this problem 3.67. I think he missed information from miss a little information, and he didn't. The problem didn't state it very clearly. Okay, but I want to make a stress here. The problem say this also h. Okay, the distance is also h. The height is h, and the horizontal distance also h. So I think this yeah this is also h. Okay, this is also h here. Okay, the position, the horizontal distance also h. Okay, the problem didn't state it very clearly in the problem. Okay, you can, if you have textbook, go to see 3.67. I think it didn't make this clear statement. But in this demonstration, I'll just tell you, okay, this horizontal distance also h. Okay, so okay, and let me write down the equation of motion. I just write here. What's the equation of motion? Xi equals to xf. Sorry, xf equal to xi plus vi x times t plus 1 over 2 axt squared. And because we have two dimensions, so yf equal to yi plus v initial velocity, but the y component times t plus 1 over 2 ayt squared. Okay. Okay. So okay. And okay, the first of all, we write down the equation motion of A. Equation motion of A. Okay, and here I just write it directly. Okay, and we set up the coordinate. What's the coordinate? Okay, let's set up the coordinate is like this. Here is y-axis, and this is the x-axis, and the origin is had here. This is the origin. Okay, so let's see. Okay, from A, what do we have? XF is h. XF is h, and xi is 0. And your x component of initial velocity is v naught times cosine 45 degree. And the flying time, I don't know, so it's t. And also this motion does not have any for A. Okay, for projectile motion, it does not have any acceleration in x direction, so that's 0. Okay, so let's finish here. Okay, stop here. And for the y, the final position for any trajectory, final position of y, I don't know. Let's leave it. Okay, and the initial position of A, y component is 0, and initial position of y velocity v naught sine 45 degree and times t, and 1 over 2, and g here is g big weight, so here is negative. Be careful because g is point down, so it's negative. Okay, that's equation motion of A. So, and let's write down equation motion of B. Equation of B is much easier, okay, because just free falling. Free falling. It's only free. It's just free falling. Okay, so x position, because h is B is doing the free falling, so its x coordinate it's always the same. So if for B, xf equal to h. Okay, and for also let's focus on y. Also for B, what the final position of y, I don't know. Okay, initial position of B is here. Here, be careful, it's h. and y is the and its initial velocity, because it's doing free falling and it start from the rest free falling. You just hold the object and then release, so its initial velocity is 0. And it only has the acceleration, and acceleration the y direction is all point down, so it's minus 1 over 2 g t squared. Okay. Okay, so let's release the equation of motion of this problem. Okay, next, do I have to scroll it down? Oh, I have to scroll it down continually. Okay, okay, we list all the equation of motion. So, what's the minimum speed of for the v naught? Okay, what's the minimum speed for v naught? Okay, so here we, yes, you need to did a little brainstorm. Okay. Okay, but this demonstration, we don't have much time for brainstorm, so just tell you, okay, what's the minimum? Let's suppose a situation. Well, what's the minimum? If the minimum, if the speed is minimum, what will happen? If we, if we, if, at minimum velocity, at the minimum velocity, mm, what would happen? If if A throw the ball with the minimum velocity and make the collision happen, at the minimum speed, that cause, I should write down the question. If I throw the ball, if I really throw the ball, if I really throw the ball, throw the object, throw the A with the minimum velocity. What is the collision point? Where is the collision point? Where is the collision point? Yeah, let's ask ourselves a question. If I throw I throw the ball at A, I throw the object at A, and I throw it at the minimum velocity, and where is the collision happen? Where is the collision happen? Yeah, from this figure. If I really throw at A, I really throw the object at the minimum velocity. And where is the collision point? Where is the collision point? You can think in this question. Okay. Okay, but I don't really have time to wait for you. So okay, let's I just answer this question for you. So if I really throw the ball at A, I just throw it with the minimum velocity, the collision point will be here. The collision point is here. Just right here. Just like right here. The orange point here, just at the H. Yeah, just like a horizontal distance H here. If I really throw the ball at A with a minimum velocity, the orange point is the collision point. Okay, at the minimum velocity, the collision point is H. Okay, is this criteria can help us to solve this problem? This gives you very important information. Okay, so let's circle this. Yeah, the y position, the position of free falling motion. Okay, I should say this is A is projectile, and B is free falling, free falling. So the position, the coordinate of y, free falling motion, and coordinate of y. Okay, look at this term. Okay, This give us the hint to solve this problem. Okay, so if I throw the ball at the minimum velocity, the collision point is at here, green point, or sorry, orange point. Okay, that means mm, the coordinate, the y coordinate, the y coordinate of B must be greater than zero, greater than zero. Okay, okay, just think think this question as yourself. Think this question yourself. If I throw the ball at A with minimum velocity, the collision point is here at the orange point. Okay, this means the y coordinate of B must be greater than zero, right? Yeah, think about think about this statement. Okay, okay. So I just keep continue to solve the problem. Okay, this is the key. The y coordinate of B must be greater than zero. Okay, okay. Think about this. Okay, so okay, we can continue do the calculation. So okay, I don't want to. I really don't want to hide this out, hide this graph. So, mm, yeah, but but everything is so important. I don't want to erase them. Okay, let's keep doing this. Okay, so this must be greater than zero. H minus 1 over 2 gt squared must be greater or equal to 0. Okay. Mm-hmm. Okay, so in this equation, okay, kind of in this equation, what is known? Okay, okay, h is given, yeah, g is given, so t we don't know. So where can we obtain the information of t? Okay, from A, so we found out the projectile motion of A. So A, we have these two equations. Which one we can get information of t? Yeah, both equations they all have t, but which one we can really get the information of t? Okay, for A, the problem is we don't know. We don't know the y-if. So this, yeah, we cannot get information of t from this equation, but this we can get the t from here because h, like I said, h is given. Yeah, the problem should state this, but the problem did not state it very clearly in the description. Okay, so h is given, so we can find a t. Okay, so I think the problem is solved. Okay, so we have the information t from here. So we have the t equal to well, maybe I should change to t equal to hv times cosine 45 degree. Okay. Okay, so we'll combine these two together. I think the problem solved. So h minus 1 over 2 gt squared is h squared v naught squared. And cosine 45 degrees squared. And cosine 45 degrees squared is just 1 over 2, right? So h minus 1 over 2 g and h squared v naught square is 1 over 2, so greater than 0. So this cancel out. Ah, hmm, over gt square. Why we have the h square? Ah, Hmm. Hey, did I do something wrong? H minus 1 over 2. Oh, I wonder why here hmm, where is something goes wrong? This cancel out. So it's GH square. Okay, let's continue to this. Maybe it's just my illusion. Okay, so this what will happen is we give the h minus b square gh square greater than 0. So okay, divided by h. So here it becomes 1. So so this here is 1. So this I it's it's 1 greater than v naught square gh. So it's v naught square greater than gh. So yeah, I did. Yeah, it's correct. So finally, it's v naught should be greater than square root of g times h. That's the minimum speed, okay, minimum velocity to make this collision happens. Okay, so it's square root of g times h. Okay, so the key for this problem is, yeah, and you need to understand, you need to have this is in mind. Okay, if this I throw this ball at the A with the minimum speed, where should the collision point be? Okay, and the collision point is here. If I throw the ball at A with the minimum velocity, the orange point is the minimums, and the orange point is a collision point. Okay, and this implies that the position, the y coordinate of B must be greater than 0. Okay, this collision point give you this blue here description. And so you just follow from the equation motion. You get the equation motion of B in y component is h minus 1 over 2 times gt squared. So this term must be greater than 0. And where should we find the flying time? Because A and B they start from at the same point. They start from at the same time. So the time for both motion is the same. So we find the t from the projectile motion here from this equation, and then they lump them together and do some algebra work. So you will find your minimum speed will be square root of g times h. Okay. So this is a very interesting problem. So that's want to share with you, everyone, and hope you can understand this problem. Yes, time of it kind of take lots of time to think about this. Okay, this question. Okay, so I just start the video here. I'll see you in another video. Okay, bye bye. It really takes lots of time. Okay, see you. Bye bye.